Yo, this is my power supply that I just made, and I'm gonna go into how I built it. So, first and foremost, what I did was I used the transformer 120 volts AC down to 10 volts AC at 3 amps, and you can see that on the transformer. If you use these red wires, you'll get 10 volts AC at 3 amps, or you can use the this one that has a center tap. If you do it from the center tap to 19 volts, it's 1 amp, or you can do the yellow to yellow, which will be 38 volts AC. But I decided to use the 10 volts because I have these buck and boost converters. So basically I put this through a full bridge rectifier, and you can see that in my diagram, put it to a full bridge, and on the output I put this 1 farad or 1000 microfarad capacitor, and that goes to this buck boost converter, and that's allows for this 12 volts that I'm putting in, and I could buck it to anywhere down to 1.1 or boost it to 26.5, and I'll go ahead and show you that right now with this potentiometer. You just can increase, and I'll put it all the way to its max, about 26.6, 26.5, and I'll put it back down, back to 1.1. And I'm probably going to change this potentiometer because it's really annoying having to use this screwdriver, but I'll put it back to 1.1 volts. And the next thing that I did was I hooked up this approximately 12 volts output. I'll actually measure it and show you guys what it really is. So this output actually is about 12.8 volts. It's just showing negative because I hooked up the probes the other way. So I'm just taking that unregulated output and putting it into a 7805 linear voltage regulator. Now this thing is not very efficient and gets very hot, so I put a heatsink and fan on it to keep it cool. And there's also I forgot to draw it into the schematic, but there's also a capacitor here between the positive and negative. There's a capacitor which is also 1 farad. That's the worst capacitor ever drawn. Let's do it again. Let me just bring these close to each other. There you go. 1 farad. Capacitor there too. That's just for this chip kind of might oscillate sometimes, just to clean up the power supply and, you know, smoothen out in your ripple. And then that goes to a USB port, as you can see, a USB port. And this USB port, I configured the data pins as follows. And the reason that I did this is because certain devices like iPhones needed the data pins to be biased to certain voltages to even charge. So what I did was I put, first of all, a 75k resistor to data positive. Then I put, that's from 5 volts to data positive. And then the side of data positive goes to ground from a 51k resistor. So there's almost a 51k resistor from data positive to 5 volts, and this middle point goes to ground, rendering that one to about 2.05 volts if we measure it. And I'll just measure that pin right now. Data positive pin, come on, 2.03 volts, 2.05. That little tiny variance is okay. And then the data negative goes 5 volts to the data negative 43 ohms. And here's the same thing, there's a 51k ohm resistor that goes to ground. And that is the way that I arranged the resistors there. And obviously these are not very common values, so I had to, you know, make with what I had and just put them in parallel and series until I got the resistance that I needed. And this thing is pretty decent at charging stuff. I'll plug in my my vape right now, and it should be pretty fully charged already. I charged it on this device already. Here, let's get it plugged in. Yeah, see, it's plugged. See, it just turned off because it's already charged. It's at full. But I also have my iPad I could try to plug in here. let me plug this in, and this should be able to charge my iPad. This is the moment of truth, because I've tried it on the iPhone and it worked just fine, but I never plugged my iPad into it. Okay, it seems like it's charging. Yep. So you can, oh, that's not my password. Yeah, you can see that it is indeed charging my iPad too. And now this thing is probably super hot already. But actually, because of this pretty awesome fan, which looks like it's spinning weird because of the lighting over here, but it is definitely spinning perfectly fine. But I feel it just getting a little warm. That fan and heatsink are actually really cooling it very well, because before I added those it was getting very hot, like 60 Celsius and above. So I just threw some Arctic Silver 5 on there and put it on a heatsink and put that fan, and the temperature now is about 32 Celsius. I'm measuring it, and room temperature is about 29, 27. So it is a little bit warm, but not too bad. Nothing compared to what it was before I add the heatsink. And now the heatsink is getting much warmer. The more it charges, the hotter it'll get. And I'll measure it again. 34 Celsius now. If you measure it directly onto the chip, it's probably hotter, but that's going to be a little difficult to do. But yeah, the power supply is pretty decent, and it's cool because I have this power supply up here, which is just a regular PC ATX power supply, and I have, you know, the 3.3 12 volts ground and 5 volts, and this one is negative 12 volts over here. I use that for op amps and stuff, or if I need 24 volts I'll hook up the ground to the negative 12 and positive 12 to the positive, so I'll get 24 volts. It's pretty useful, but it's kind of bulky and I can't move it around much. This one is a bit easier for me to move around, and I'll keep it down here so that if I'm doing a project and I don't really feel like doing it on the shelf, I can do it down here too, and I could have a easier to manage variable voltage with this too. Now the efficiency is not the greatest on this part because it's a linear regulator, but these are switching, so this is a bit more efficient. But you also have to remember we're using kind of this old method of doing it with just this transformer and a full bridge rectifier. Now the way most switching power supplies work, which this is not working like that, but they'll take the just say this is your 120 volts AC, and they'll put it into a rectifier, and then I'm too lazy to draw one, so I'll just say rectifier, and then from there, from the rectifier it goes to a lot of capacitors, and then from here you have some kind of a transistor switching circuit over here that it goes into, and then that produces switching DC. So it'll switch really fast, and then since you're at a high frequency, you can use smaller transformers with thinner wires over here. Once it's already been rectified and is switching at a very high speed, you can use thinner transformers, and that's where you go to your 12, 5, 3, -0, -12, whatever voltages you have. And there's also, you know, feedback systems between these to, you know, if this voltage goes too low, then it'll say, hey, I need more power. Then that's not what we built, because it's kind of complicated to make. So we just went with this design and made it as good as we possibly could. And as you can see, I also put a heatsink on this too, because this doesn't get too hot, but it's getting a bit warm. This gets a little warm too, and this gets, depending on what you're doing, that gets really hot. That's just that's the switching transistors on this, on the buck converter. and that's the boost converter. And little known tip, if you have a buck converter and a boost converter and you want a buck boost converter, hook up the output of the boost converter into your buck converter and set the boost converter to the maximum voltage, and with this one you could just control it to buck or boost. It's a little known trick. I thought I'd show you guys. So anyways, thanks for watching the video, and I hope you guys learned how to make your own power supply and how I made mine. And be sure to like and subscribe, and if you don't feel like doing that, then whatever. Thanks for watching anyways. Goodbye.